Today we have the special function, the exponential function with base e, and we have here, this is how it look like for the integration for the exponential, the integral e to the power gx, the function gx, multiply the derivation of this gx, it will be egx, and the derivation of this exponential function, as we can see, e to the power g, we will keep it as it is, and we will take the derivation of the gx. This formula for the derivation and this formula for integration, we should memorize it because it will use it to solve the integration and derivation for this exponential function, because we will put the function in this form if we want to find the integral, and we will use this form to find the derivation. In a practical way, we will see this picture, it will be more clear. Let's see another point. The most important notes about this type of function, the domain of this function is all real number. Another point, this exponential function is an inverse function with the natural logarithm function. As we can see here, is inverse function. At this point, it will be useful if you want to make simplification, if we have some function need to be simplified. So we should know about this. Properties of an exponential function for both the real numbers. We have some properties for the exponential function. In the case of multiplication, we add the exponent. If in case we have multiplication, e to the power a multiply e to the power b, we can add the exponent. It will be e to the power a plus b. In case of the division, if we have a divided by e, we subtract the exponent. So it will be a minus b. If there is more than one exponent, we can multiply these exponents with together. In case if we have it in this form, we can multiply the exponent. Let's see some examples. Find the derivative of the following function. We have this function. We see how we will find the derivative. It will be the solution. It will be just direct application for the exponent function derivation. That means if we have this, we need to find the derivation of this part. If we have e to the power g, we need to find e. We will keep it as it is. We will put it as it is and multiply the derivation of gx. So it will be e multiply the derivation of gx. Let's see how we will do it. So we have e, we will keep it multiply, we will take the derivation of 3x, and it will be 3, the derivation of 3x, it will be 3. The second one, we have this function. So this is under root. This is a special form to find the derivation for root. Throw it forward and we will deduct 1. It will be minus half multiply with the derivation what is inside the root symbol. Here we have ln. So what is the derivative of the ln? It will be 1 divided gx, this is the gx, multiply the derivation gx. We will find the derivation of this one. Same here. We will keep the exponential, we will keep it as this, multiply, we will take the derivation of the gx, this is the gx. We will take the derivation of it. And notice here, this is the derivative of two functions multiply with each other. How we will find the derivation if we have function like this? First, this is the first function, this is the second function. First, we'll keep the first function, x, multiply the derivation of the second function, this one, it will be 1 divided by x, plus the derivation for x, it is 1, multiply the second function, ln x. This is a special form if we have two functions multiply with each other, how we will find the derivative of it. Anyway, let's go to see about the integral. Find the integral of the following function. Let's see how we will solve it. Just remember, this is the special form of the integral or the exponential function. We need to find the derivation of gx. So the integral result, it will be e gx. Let's see. This is simple. What is the derivation of this is exponential function with integral? So what is the derivation of this x? It will be 1. What is the derivative of 4x? It is 4. So we'll multiply 4 here, numerator, and the denominator will multiply by 4. So the final result of the integral, it will be, this is the original function. It will be 1 divided by 4 multiply e to the power 4x. Same here, we have exponential. So what is the derivative of x to the power 6? It is 6x to the power 5. We have x to the power 5. We will just multiply 6 in numerator and divide it by 6 in denominator. And we will get the original function. Same here. What is the derivative of the root x? And we will get, this is the derivative of gx. It will be 1 divided 2 multiply root x. Simple. The second one. So we have exponential. So what is the derivative of this function? We find directly. This will be 4x, and we will get the result of this function. So the original function, it will be this one. It is just simple application. Same here. The integral for this function. What is the derivative of 2x? It is 2. This is already in the special form of the exponential function. So it will be, this is the result. Let's see this one. Integral e to the power tan x divided by cosine square. What is the derivative of tan? It is sec square. So here 1 divided by cosine square, it will be sec. This is sort of simplifications. And later on, e tan x, we will keep it as it is. So now, what is the derivative of tan? Sec square. So it is already in the special form of the integral for the exponential function. So the integral result, it will be, this is the general function, it will be e tan x. So for the next integral, same concept. What is the derivative of this function? It is 6. So we will multiply 6 in numerator and denominator. So the result, it will be this one. Next integral. What is the derivative of this function? It will be 4x to the power 3 plus 6x. We already have x here, so we just multiply by 2 in numerator and denominator to get the derivative function of this function. And the final result, it will be this one. This is for today's lecture, and see you next time.